Yes.
I can hear you breathing in the microphone. Can you put your microphone sideways?
Okay. Now it's better?
Yes. Yeah. Good.
So I started the recording, so I think you can see that the recording is being activated, right?
Yes. Yes.
So now we'll share the application. Now you can see the slides, right?
Yes, we do.
Yes?
Yes, we do.
Okay, thank you. So Pascal is not doing yet, but I think we can start. Um, Welcome everyone. This is the second interim meeting for this year. Please be aware that this is aligned with the notebook. Those are the meeting materials. Please put your name into the Etherpad. It works as blue sheet. Okay, this is the agenda. So we're going to talk now about the IETF 108, what could we do? And then Pascal is going to introduce us adding the information. Then Raul is going to talk about the new option of backward compatibility. Then we can discuss about the compression, if how it's related to entity extension, if we can move forward with the document or we need to indicate something there. Then Raul is going to expose these group observation topics that are still open and his new work in group acknowledge. Some comments about the agenda? Okay, thank you. So for the IETF 108, we have that the meeting is going to be like 5 days, every day with 5 hours, between 11 to 4 UTC every day. And the slots are going to be for 15 or 100 minutes, with 20 minutes break. And they're going to plan 8 tracks in parallel. So with that situation, what do you think the working group is the best for us? It's like we meet during IETF 108 or we meet after, right after, and like we did last time. And how much we will need? What do you think? How many slots? What do you think? Someone want to comment?
Well, yeah, as a participant, I'd rather have the meeting during the IETF week because it's more focused and it's easier for me to explain to my employer that I'm at the IETF for that week and not doing something else in the meantime. That's just my opinion.
So sorry, for you, it's better to have the role meeting during the IETF 108?
During that week, yes.
Okay.
That's my vote.
Okay.
So it would be in approximately 8 weeks. And it's been approximately, we had an interim about a month ago, I think.
Yeah.
No, even sooner than that. So I do like having these interim meetings. I think they're more productive. We are missing Pascal, but I'm concerned that the 8 tracks in parallel mean that we will have some conflict and we won't have all the people we need anyway. So I'm not opposed to having a meeting, but I don't think we need more than 1 slot, and I think we should still plan on having another interim, having other interim meetings.
Okay. Thank you, Michael. Well, I think that yes, that week is going to be very crowded for everyone. I think so. For me, works like I think it's going to be easier if we meet like after ITF with the interim meetings. We can have 2 hours, and I think people are going to be more relaxed that attending tracking in parallel in case that they have several works. But well, it's up to the community what they want we do it. So it would be nice if everyone can expose what they think. We have. So additional comments. So maybe we can have this to the mailing list.
I mean, I'm from my side, I'm okay with either options. I mean,
Okay.
or during the IETF, I don't mind at all. George here.
Okay. Thank you. Okay. Thank you very much. So probably we will ask to the mailing list to get the confirmation and see what else is better. For
If
the
it's,
yes.
if it's not during the IETF week, I recommend we don't do it after, that is August, because it's not a good time.
Ah. Okay. 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 We will track all these comments and decide the best course of action. Thank you very much. So, well, if we made in the ITF 108 with one slot, will be kind of okay, and then we meet in interim in case needed. Okay. Take note. So then Pascal is not yet here, right? Participants. Okay, Pascal is not here, so we can go to
Email. Can't find him in
Raul.
chat anywhere.
Sorry, what do you say?
Sent him an email, but I can't find him on any chat that I have. He should be on the Cisco internal chat, but I don't have him. I mean the Cisco WebEx Teams, that is. So
I don't have in chat.
I haven't found him, so I don't know.
Yeah, so we can jump to Raul. It's fine.
Okay, so
Thank
you
you.
know, if by the end of this meeting, if Pascal doesn't come back, I would like to come back to his slides, gone through his slides and see. Right. Okay. Okay. So this is about the backward compatibility issues that we have been having for all the new options that we have been that most of the drafts are bringing forward. One of the major issues is that whenever we have a new extension, we have a RPL extension, it's in the form of a new RPL control option. And naturally, some of the 6LRs or 6LNs who don't know that will be dropping those. So we had the same issue with capabilities. So we thought that maybe in the future, if some node doesn't understand the capability, then they will drop it. So we introduced some features such as if a node doesn't understand the capability, then it has to still copy it forward depending upon another bit. So the same mechanism has to be introduced for RPL control options is what we think. Now we cannot be as flexible. So what I have here are two proposals. One proposal is in which we don't increase any control overhead, but it may not be as flexible as we might want it to be. We might be able to just manage the copying mechanism, but in the last interim, Pascal mentioned that apart from the copying mechanism, if we can have similar but that is slides. But On this slide, basically, I have two examples. One is the enrollment priority, which essentially defines a new control option, the mean priority, which has to be. I'm sorry, can you please go back to the previous slide?
Yes, sir.
Okay, so enrollment priority has mean priority. There is a control option and it has to be copied. And there is another draft which is eliding RPL option, which introduces a new AOO option, which essentially which says that ideally a 6LR should not copy forward this option if it doesn't understand. So currently, RPL RFC does 6550 doesn't say what has to be done if a control option is not understood. 6550 is very clear about how to handle if a code is not understood. That is, a message should be silently ignored if a code is not understood, but if a control option is not understood, there is no clarity in the document. So basically for eliding RPL option or eliding RPL info, what we need is a mechanism in which 6LR should be dropping the option if it doesn't understand. It will be catastrophic if an option which is not understood by a 6LR, if a AO option which is not understood by a 6LR is not stripped off but carried forward. So these are the two current problems that we have already. Next slide, please. So the expectations are very straightforward. The first paragraph says that at least we need to have a mechanism in which the option should be carried forward, copied as it is if it is not understood, or the option should be dropped altogether. This has to be explicitly stated in the RFC, in the document. There are, however, more possibilities, just like capability flags. We can have a flag which says drop or discard the message if option is not understood, or join as 6LN if option is not understood. It's not very easy to handle the subsequent flags. I'll tell you why in the subsequent slides. Next slide, please. So the first proposition is a very simple one. We have the second high order bit. Now, during our last interim, I mentioned that we can have a higher order bit to indicate copy flag. But I missed out on one point that the high order bit has already been made use of in 6550 for the secure options. So we cannot use that. So all we have left is the second high order bit, but it means basically the C flag can be added there. This would mean that there won't be any change in the existing implementations so there won't be any increase in the control overhead at all. But at the same time, we cannot afford to have more bits such as join and discard like capabilities, because it would simply reduce the entropy of option type. Look, when I say C, it doesn't necessarily decrease or reduce the entropy of the option type, because that option is that option is still valid. What I'm trying to say is, if a C flag is set, it means that value is actually getting used. So all the others can be zero and C flag is used. But if we have join, discard, then eventually we are reducing the entropy of option type, and we may not be able to, if we have join and discard, something like 32 options will be remaining, and we are already using 20. So that is definitely out of question. So this is what is one proposition. The other proposition is on the next slide. Next slide, please. So here, what I'm suggesting is we have a X flag, extended option flag, and then after the option length, we have the 8-bit option field. This is definitely more flexible. It would still work. It would still be backward compatible with the nodes who don't understand X. But it would essentially mean that all the extended options have an additional byte that has to be carried forward. But if we have this, then we can have newer flags for option types as well, for different options. So these are the two propositions that are possible, in my opinion. If someone has any other idea of handling this, I would like to understand. Next slide, please. I don't know whether there's a next slide. Yeah. Yeah, so one of the thing is we would like to clarify this in the MOPEX draft and not the capabilities draft, because essentially MOPEX draft is the draft which basically takes us forward to RPL v2, and we would like this to be managed. It's not logically speaking, it's not something that capabilities have to handle. It should be part of MOPEX in my opinion. But again, this is something that is open for discussion.
So in RPL v2, would we just implicitly say the X flag was set, and then we would get that?
No. Yeah, so let's assume that the X flag, so there are two cases. Let's say, for example, there is an RPL v1 node and RPL v2 node in the same network. RPL v1 node is not going to understand the X flag, but it would still be able to skip, or it will be doing the same thing that it was
Understood.
doing before. Yeah.
But let's assume that we moved to an RPL v2 with a new MOPEX.
Okay.
Would we still need the X flag, or could we?
No.
We could just assume that all options from now on have the extra flags.
No. We should not assume that. So what I'm proposing is that the X flag only can be added for those options which need those extended flags. So we can still have the same old style option types in place with RPL v2 as well. But if a certain option requires an extended flag, that can be set, and RPL v2 nodes will understand that flag as well. So it won't increase the control over it for those traditional style, old style options.
But here the RPL version V1 nodes, they have to understand that X bit in the type, right?
Yeah, so they won't understand. So that is naturally RPL v1 is not going to understand that bit. So the only thing that kind of node can do is skip that option, because anyways it doesn't understand that option, right? That option is applicable only.
Unless until we mark, okay, this option is optional or this option is mandatory, depending on that they have to decide, right?
No, let's say there is a new option which requires the X flag. Okay. Now let's say that this option goes to a RPL v1 node. All that RPL v1 node can do is skip this option. It can either strip it off or copy it. 6550 is not clear about it, so we can't do anything. So what I'm saying is we have a handling which is synonymous to the current handling, or is same as current handling for RPL v1. For RPL v2, we have extended flag which increases 1 byte control overhead for options which require this extended flag.
We cannot keep it simple like in V2, like in IPv6 extended headers. They say it is optional header or mandatory. If mandatory, you have to process is optional. You can either skip or you can just forward. So in V2, cannot we keep some that if first 2 bit, any first bit you are saying it is a secured bit, secured or unsecure. Next bit it can just say if it is set, then it is a mandatory, or it is not set, it is an optional. So using this first 2 bit only, any old nodes or new nodes can decide whether they have to process the option or they have to skip the option.
So Rabi, essentially what you're saying is the same thing, isn't it? I mean, RPL v1, we will still run into a situation where RPL v1 won't understand this, right? And so
When somebody like the old legacy code means who have already implemented, what they would have been doing now, they would directly checking the type and deciding. They would not be doing a bitwise check. Okay, this bit I need to check.
for security, yes, we do check, right? I mean, apart from security, no one implements security. That is a different point. But yeah, for security, one has to check the bit. So what is your point? I'm sorry, Ravi, I'm not sure if I got you properly.
I'm saying instead of making that extra 1 byte you told, right, in the previous slide.
Mhm. Can we go to the
If I
previous slide?
currently we have only option type and option length, right?
Yes.
Depending on X bit, you will decide this option flags, right? Because new options may have these option flags. Okay, I mean to say, if we use this X bit to just to say, okay, it is a mandatory option or an optional option. In that case, like old node, they can, for them it is maybe all the new options can be considered as optional. If they don't understand, they can simply skip.
But isn't that what I'm saying? Isn't that exactly what I'm saying? So if the X flag is set only, then the option flags come into picture.
Okay.
Right?
Okay, got it.
I would love to have this, Rabi, if you still think, maybe we can have this discussion on mailing list. But yeah, yeah, definitely let's discuss that.
Yeah, this proposal number 2 seems good for me because it has more extensibility in it.
Thank you. Thank you.
I see a comment by Carsten in the chat as well. Maybe Carsten, you want to jump in at the mic?
Yes, I just wanted to propose a couple of terms here, because talking about optional options and mandatory options is confusing pretty quickly. So in CoAP, of course, we ran through exactly the same kind of situation, and we came up with the terms critical and elective options. So an option is either critical or elective. Of course, Ripple would need to define what you actually do when you get a critical option that you don't understand. In CoAP, that's easy. You can just abort the transaction, but in the routing protocol, that's a bit more complicated. And then we had another bit. We have another bit called safe to forward, which means if you don't understand it, you can still pass it on. And here, of course, you wouldn't use safe to forward. You would just use forward, even if not understood. So I don't know if you have any other parameters of option handling. In CoAP, there are a few more, like no cache key and so on.
Thank you, Gaston. Actually, those are the flags. So elective, critical, and safe to forward. These are the 3 flags that we are looking for. And the X flag that is shown here just says that option flags will hold these values. So if we follow proposition 2, we can have all the 3 flags. But if we follow proposition 1, we may not be able to have all the 3 flags, like you mentioned: critical, elective, and safe to forward. Right.
The
This
critical
is exactly
is one. Critical elective is one flag. So when it's set, it's critical.
Right.
When it's not set, it's elective. And safe to forward is another flag. In CoAP, we need a few more, because things are cached or not cached, and so on.
Those are critical and elective is one flag for us too. But apart from and copy is same as safe to forward is what I believe. The other thing that RPL has is a node should join as a 6LN if a flag is not understood, or if an option is not understood. So that is one more primitive, which is RPL specific, which may not be generalized, which cannot be generalized. So these are the 3 flags that we intend to have.
So essentially,
Join as 6LN. Yeah, 3 flags.
Essentially, you define the set of option flags that are set when the X bit is not present, and when the X bit is present, then you can do it explicitly.
Yes. So that's about it. So just to confirm the last statement. So only when the X bit is set, we can have these 3 flags, which can be used in the new in proposition 2. In case of proposition 1, we cannot have 3 flags at all. But yeah, I mean, it's not flexible at all in proposition 1.
Okay, thank
That's
you.
all.
But in case of the X bit is there or not, right? Option in RPL version 2 option flag will always be there, right?
No, it's not there. So only if the X flag is set, option flags will be there. If X flag is not set, then it's just the same old style option type. That makes sense. Yeah, I mean, yeah.
Okay.
And so the proposal is if X is not set, the behavior that we just described, critical elective, save to forward, join as leaf node, those need to be implicit. That should be known from the option type.
Yes.
Okay.
Yeah, you just define
Earl,
the
I think
flags.
that you're also hearing that option proposal 1 is not that popular. I don't know if that was implicit in everyone's comments. And then I think that you're also hearing that, yes, you should do this in the MOPEX document, and that we need more examples to discuss so we understand the what's happening.
That's right. So we already have existing examples. So I'm hoping that existing use cases at least we can satisfy. But this discussion is almost similar to the capability bits discussion. So we have pretty much thought about that for a long time. So I'm hoping that the same experience will hold true here.
Yeah, maybe you can do some combination of these kind of 3 flags with these optional or mandatory capabilities, like combinations.
Sorry. So
maybe you could specify examples like combining these kind of 3 flags with the capabilities when they're mandatories or elective. Optional.
No, sorry, Ines. Actually, Ines, this has got nothing to do with capabilities. There is absolutely no coupling between capabilities and this. I'm just saying capabilities because we have the same flags, same semantic, which can be applied here. But I mean, there is no relation between these flags and the capability at all.
Thank you.
Okay, let's get to the next one. Is that for me? The next one?
Yeah. So next topic that we came in the last interim was about the compression of ripple control messages. There was a previous work in 2011 that was proposed DIO compression and the configuration option compression there. But the document did not went forward. Then as well we have the generic header compression. So we start discussing how will be the compression of the ripple control messages. So we can start like a brainstorming, but as well to move forward with the NC extension draft, we want to confirm in this meeting that we don't need additional features in that document that is related with the compression mechanism for the IP addresses of the NC extension draft. So if, I think last meeting we agree, but we want that for confirmations. If you think that we can proceed with the NC extension or that needs some compression mechanism.
I think, George, I think what we said last time it was that we do need compression mechanism to be generic for any other
control messages.
Exactly.
Yeah.
So from our side, we are open to contribute for a new work that will be generic for a generic header compression for the control messages. So we are willing to contribute.
Okay. Thank
We can
you.
initiate.
Thank you very much.
So one thing that we should do before, and this is something that I'm not clear about is how much. So we have aggregated targets. We have parent set from NS extension. We have parent address, and we have address vectors in case of RPL, AOTV, P2P, RPL. So we have a lot of addresses that are going through these control messages. I'm just wondering that how much of compression can GHC actually bring? So if GHC, if we are, how much would we be optimizing if we will be putting in our new primitives? You know, if that optimization is maybe 5 to 10%, I don't know, but if that optimization is maybe 25-30%, maybe it will be. So what I'm data first, and I've not seen the GHC RFC, but I don't know how the numbers will look like. So it would be great if someone before, Georgios, if we can have some sort of numbers for GHC. Does that make sense? I mean,
I don't understand why do you need such number, right? I mean, there are many different drafts that they are extending somehow the control packets, right? And that you may potentially include or not the IPv6 addresses. Whether now
so what I'm saying is
the best one or not, the good one, another story, right? So we can either use GHC or I don't know. I don't know actually this draft, right? So
GHC got me very trivially 50% compression with a very naive compressor. That was like 8 years ago that I did the test, and it was like 30, 40 lines of C code. Like it was the stupidest compressor possible. And I got very, very good numbers on control messages because there's lots of zeros and stuff in there. So can try again with newer stuff, but it's the best is if we get a library of sample packets that are representative, right?
So in my opinion, actually 50% compression may not be good enough because if you see the 16 bytes, if an address is compressed to just 8 bytes, I mean, in lot of cases, it may not be possible to compress to below 8 bytes. But yeah, again, maybe we should. Maybe the scenario that you used was may possibly give you only 50% compression at best case. So I have sample packet sets if anyone's interested, with all this control messages, except for PS set, and yeah, I can
George, Georgios, I think you had implemented 6-low type of compression for those packets.
yes.
So what kind of compression ratio did you achieve with that? Can you answer Raul's interrogation?
6 LoRa helped a lot. It's essentially reduced. I don't remember the exact numbers, but I remember that we could indeed include many IPv6 addresses. We dropped out 6 LoRa because again we came back without compression. But 6 LoRa helps a lot. I can check the numbers and I can send you if you want. The thing here is that, to me, I don't understand why we need to link the generic compression, any generic compression that we are going to work on with NSA extension. I mean, we may have a standalone compression mechanism that can be applied to any other protocol, including NSA extension. This is my main concern.
Right. Exactly. I agree with you, but the reason why I think several people are worried or interested in looking at figures is that in this case you have a list of addresses, and so compression is really badly needed. And the reason why I said I would want to have a vision for how compression is going to be achieved is that some other mechanisms, like the first draft that, by Mukul Goyal, which is listed here, is an ad hoc compression. It takes each field and figures how it can be represented on fewer bits. And so if we need such kind of things, then we need to have the hooks, the flags, the reserved bit somewhere in NSA to do this ad hoc compression. But I'd much rather go for a generic mechanism. So that's just what I wanted to sense. If everybody agrees with that and is ready to go in that direction and work on a generic mechanism, either for compressing addresses or for compressing any kind of header, then I'm fine.
So
that was my intention, that there was a conclusion from the previous interim.
also, we need to negotiate compression, whether it's going to be used. And so it fits into the whole capabilities document as something we might want to negotiate. And it seems that we're creating a lot of interesting extensions. And so it might be good if people could optimize less because they could assume compression. Just say in the silence that I've texted and messaged Pascal through 3 or 4 different ways. And I'm a bit worried now.
Yes, so did I actually, and then SMS as well.
Just for the record, we have currently 3 types of compression, right? So COMPR, which is P2P RPL and RPL AODV is making one type of compression, using one type of compression. 6-law RH is another, and GHC is another. So 6-law RH, if we discussed before that maybe 6-law RH might become a norm with RPL v2, and if it does, then we might have something like that be used in all the context.
Okay, so it seems I'm hearing everybody agrees that we will have some generic compression mechanism, something that works across Ripple options, and so you don't have to do anything special for anything. And as Georgia said, maybe we already came to that conclusion last time. It's good repeating
but this would mean would this mean updating the NSA document, because the NSA extension currently does not do any compression, or if 6-law RH has to be done, then maybe it has to be provisioned now, because 6-law RH is already there, and we are also closing on for RPL v2. So what I'm trying to say is, you may have to provision.
My original question.
Okay.
That was the original question. Do we need to provision something to say this is the uncompressed version, this is a compressed version, or will compression work above these options, irrespective of their encoding? I mean, their flags or whatever.
I believe so. We should do this. Yeah.
I didn't understand what Raul you meant, but what I'm seeing is that you are having the flags before, and then you don't care what's inside, right? So it can be with or without the compression. It should be work in both cases.
Yeah. So right now, NS extension doesn't have any flag at all to say that there is a compression, or that it is compressed or not compressed.
No. But if NSA doesn't have, because the IO will have this flag, then it will be automatically inject into the NSA, right? So yes, this was the same, yeah. Vision to put the flag.
So,
Do you want to put inside the metal container or outside?
Yeah, I'm not sure about that. Yeah.
I think it should be outside, and if it is outside, then it has nothing to do with the MC, which is the NSA. Same with the siblings, right?
Okay,
If a node will give the siblings the one of the work of Pascal, situation, right?
Actually, I'm not sure if I'm hearing you properly. I'm sorry, but I can hear a lot of breathing sound, and then
Ines,
in between.
Ines, I think you're breathing into the mic. Thank you.
Yeah, thank you. Yeah, so sorry, Georges, can you please repeat what you said last?
I mean, what I was trying to say is depending where we want to place the flag, right? If it's going to be in or out of MC. If it
Yeah.
outside, if it's outside, then we do not need to touch NSA.
Okay.
And like this, if it being outside, then it can be applicable to any other work that requires such compression.
Right. Yeah. That's true. That's true. Okay. So
I think I'm
maybe
hearing
but yeah.
I did not understand what you said, guys.
Yeah, sorry, we stepped over each other. I think we're saying we want compression for a lot of options, and for options we already have, for options we're going to create in the future, and so we gamble that we're going to be able to do good compression over all options, and so we don't need a hook in this one.
Yes, this is my understanding.
Anybody opposed to that conclusion?
Write it in the Etherpad.
Yeah. Will do.
Okay, thank you. We move forward. Howard, please.
Okay. So these slides are not going to be detailed slides. Most of the problem statements about RPL observations present more than a couple of times in previous IETFs in physical sessions. So the aim for this discussion is that I have a list of all the points in RPL observation draft, and I've mentioned the current status and the possible next steps. In some of the cases, I don't know what the next step should be. Some of the work has already been initiated for some of the problem statements. For some of the problem statement, there has absolutely been no progress at all. So let's go about point by point. So first is the handling DTS and increment problem in storing mode of operation. Right now, the way I see it is that it's very difficult to get interoperability in place for between implementations, for example, Riot and Contiki, just because the way in which the TTSNs are incremented between these implementations. Specifically for storing mode of operation, there is no clarity available from 6550. For non-storing mode of operation, there is absolutely no problem because root is controlling everything. A lot of problems how this DTSN increment is handled results in a lot of control overhead, a lot of especially the sub DODAG route update completely depends upon this. Previously, we had a discussion wherein Pascal mentioned that sub DODAG route update problem is a different problem. A 6LR, when it switches the parent, updates sub DODAG routed at that node to its preferred parent, the new preferred parent. So there are a lot of options there. Not sure if we should handle it in a BCP or so all these points are actually mentioned in the draft as to what are all the problems and what are all the deliberations that have to be clarified if someone is putting up this best practice. But the way I see it, there is no change. At least as of now, I don't see any change that is required in the standards for that. But if someone can optimize, actually, then someone can think of some change. So as of now, I think it may be a BCP document. The second one is about DAWAC handling. So the problem was the end-to-end traffic has to be initiated by the node only once the end-to-end path has been established. So that is one problem. Also, if a node switches the parent, in some cases, the 6LR might want to know if that parent, if it was able to establish a complete end-to-end path through this new parent. So again, this work is already in progress. So there is a draft for this, so I won't go into the details. So interpreting trickle reset is the next point. This came up because there is resetting trickle back to the min, or resetting the trickle timer within the current timer. So there were two interpretations. Maybe this should be clarified. RPL observations already clarifies it, but since RPL observation is not going to be a published document, so I don't know whether it warrants a new draft or whether it can be used. All these things can be combined together in a single BCP. Point number 6, the section 6 talks about handling resource unavailability. What it means is, in case of storing MOP, a high level hierarchical, so a node 2 level up may not be able to signal its resource unavailability to the node below. But now, in some way, mean priority handles it. The mean priority field should be handling it. So I think we are good for that. But I try to check if there are any deliberations which may not be handled by mean priority. I couldn't find any. So I think that should take care of it. Section 7 talks about handling aggregated targets. Now, if a sub-DODAG during parent switch, if a 6LR updates the complete sub-DODAG at its point to another preferred parent, then there will be a lot of sent as part of the DAO. It definitely makes sense to aggregate those targets and compress it if possible. Again, there has been some discussion about compressing these address vectors, and I'm hoping that whatever existing mechanism or new mechanism that we talk of will take care of this problem statement as well. Then there is transit information option. There are certain fields such as path sequence, which are mandatory for operation, but RFC doesn't mandate it. So whether this should be mandated, or how this should be handled is another point. Section number 9 is upgrades to RPL. Now, when I wrote this section, I didn't think only from the control options point of view, which we are sort of handling now, but in general about all the other places also where usually the backward compatibility or upgrades have a problem. But in my opinion, maybe backward compatibility option handles it in the most of the questions that I have raised in that context in RPL observations are answered by backward compatibility. So yeah, I don't know if anyone else has some other point with regards to upgrades in general for RPL. Next slide, please. Next slide, please. Ines.
The slide is current status continuation. That start with 10. Path control bits handle.
I don't see the new slide. I'm not sure if others can see it. I'm still stuck on the same slide as before.
Okay, I changed it. Current status.
You changed it, huh?
Yeah.
Okay.
Will you see the rest?
I can't see the. Okay, now I can see it. All right. Okay.
Yeah.
So section 10, it's about. Thank you, Ines. The path control bits. So this is an interesting observation because 6550 says that the path control bits are a mandatory fields. And interestingly or surprisingly, none of the existing implementations actually follow that must clause. So what should we do? Actually, the path control bit should come into picture only with multiple preferred parents. But RFC 6550 says that even without multiple preferred parents, path control bits have to be set, indicating at least one path is reachable. But none of the implementations currently do that. And none of the open implementations currently do that. So wondering how should this be handled? Next is section 11, adjacency probing with RPL. I think George's draft sort of covers it. It not sort of, it actually covers it properly. And I guess it's up for adoption. Then we have eliding. So how do we handle? So there is a lot of static information which flows in DIO all the time. Eliding RPL info essentially takes care of it. It's in progress already. Next, point number 13 is very interesting because I remember we had discussed this and we had said that lollipop counters, the linear part has to be backed up into the persistent memory to avoid problems. So we still are saying that we still need persistent storage in the linear part of all the lollipop counters. This is a problem for a lot of deployments. This is certainly a problem for the the deployment that I'm working on. So I'm wondering if we should handle this problem wherein either we make the linear part small, or just making it small won't help. We may need some other work. So one of the interesting point is Pascal has handled this problem in a very interesting way for the new option that he has suggested for the AOO option in the eliding RPL info draft. So what he has done is he has used so the RCSS. So the new options. So what eliding RPL info does is it avoids sending the static configuration all the time. It does this by sending a counter in place of all that information. And if you see the same counter, you know that the same information is well. What Pascal has mentioned in the draft is if until and unless the lollipop counter goes into the circular part, the whole information has to be kept on broadcasting. This eliminates the need for persistent storage altogether for that lollipop counter. Something similar if it can be done for TTSN, DODAG version, and a lot of other DAO sequence, I guess, don't have problem, but all other lollipop counters. Section 14 talks about capabilities. The capability draft is already in progress. And section 15, there are a few points about RPL under specification where 6550 is not clear, and I feel those are not a big deal, but they might just need some clarification. Actually, those points were clarified to me. They were not clear to me when I implemented stuff, and then they were clarified to me by the working group, and then I moved it to the under specification part here. That's all. Actually, these are the 12 points. So it looks like we have Pascal online as well.
I'm sorry, I had entered the meeting for 2 hours from now. So I don't know. I'm sorry.
Okay.
It was 6 a.m., which I understood as being Pacific Coast or something. I don't know. The other way around, actually.
Okay, so
No worries. We shifted your presentation to later in the meeting. You still have a slot.
Thank you, Dominique.
Welcome.
So basically, through the slides, what I'm trying to say is, in some cases, I don't know what to do, or maybe working group should decide what to do for those points, or or have just a PCP and put all the points there, or not sure what to do. A lot of points are already handled in one way or the other. Yeah, the eliminating need for persistent storage also we had discussed a lot of times before, and I feel this problem. This has to be handled one. We can't. It's not acceptable that a deployment has to depend on a persistent storage just because it uses RPL. Because if the application doesn't depend upon any persistent storage, but RPL and then it depends upon it. So.
Raoul, I was already there when you started discussing the persistent storage problem, and I think we kind of discussed it, but maybe it was one-to-one in the past. So there are two things that you can do. One is not to use a straight part of 16, right? I mean, it's the max, but you could actually start at 254 or something, and I guess that's what you had in mind when you mentioned my other draft on synchronizing the options. And so if you start at 250 something, then the straight part is very narrow. So you have control on that in any given spec, and even in the implementation, I guess we could say, hey, you can configure it, for instance, while you start. And then if you have something which kind of advances quite quickly, even if you start at 248 or I don't know, if you increment quickly, say somebody has a level which is 252 and you start at 248, after 4 iterations, you'll pass him. So if somebody is stuck somewhere in the straight line, there is a point where you will pass him. For DIOs, I mean, when we discussed it, you mentioned that sometimes the DIO don't progress very quickly. And if they don't, then we can stay stuck for a very long time. So exactly. it has to do with how you advance in a straight line. So the implementation could make sure it stays only for a certain duration inside the straight line, for instance. We don't have a spec for that. When we do the report v2, when we do 6550 bits, just like your errata question, when you do 6550 bits, we could say, hey, there should be a parameter somewhere, which is how long you can stay in the straight line. And so after that, you have to go in the round space, and so you will pass whoever is stuck in the straight line. So this is something that we could do. There is another thing that we could do yet, which is each time the root reboots, it generates 4 bytes random, something like that, and you place it in the DIOs just to say, oh, it's my random boot blah, with like 2 bytes or 4 bytes random. You have a good chance that it's a new something new. So if somebody has history about what you did in the past, and he sees a random that was never there, then it's newer. That's the sort of thing we could do. Now, how we specify this beyond what people can implement? I mean, I believe that at some point there will be a 6550 bits. When we are ready with Ripple v2, look at what IPv6 has done. They basically matured a good number of specifications around 2460, and then they did 8200, and they did 201, and 202. I mean, they did the family. So they have a consistent thing. So now you're working on capabilities and MOPACs, and we have DAO projection, we have use of Ripple info, etc. So we are building all those specifications, and so there will be a 6550 base to gather everything, which will be starting at a MOP above 8 or something. And so that's the time where your draft will really come handy, because it's the early list of what we need to fix. That's how I see it.
So Pascal, so this is what I gather from. So there are 2 approaches that you have mentioned. One is reducing the window size, sequence window size, That is one possible option. The other possible option that you
line.
mentioned was sending to the straight part, the window sequence. The sequence window should be reduced. That's the state part. So the other option that you mentioned was sending a random information from a random 4 bytes from the root.
For the first
Interestingly,
piece, there was an option to have a time bound as well, right? Say you can't stay more than 2 hours in a straight line. So after 2 hours, you move. You have to increment and move out of the straight line.
So, Pascal, the observation drafts, one more thing, what we have observed is that it may not be necessary for all the sequence counters to be handled in a generic way. For example, DTSN might need a specialized hand. And path sequence and DTSN are the most critical. Version, tau sequence may not have problem. So what I'm trying to say is, maybe a common sequence, lowering the sequence window for across all the sequence counters, it may not be needed, is what I believe. One more thing that I want to mention.
I did not mean to do that. Basically, Section 7 of RIPL gives you a generic mechanism. And then, as you say, for each counter, and I have one, as you mentioned, for the synchronization of options, we may say, oh, within that generic framework, which has a straight line up to 16, we'll just use 2 or 3, or we'll put a time bomb, or whatever, or we'll, that's so. I'm not saying do that for everyone. I'm saying you have the option, but yes, I agree. It could be for each individual.
Okay. So one more thing that I wanted to just confirm with you, and Pascal, this is about the draft and the handling that you have suggested for AOO option in the eliding RPL info. So it also has a new lollipop counter that is added, but you clearly state in that case that unless and until the lollipop counter goes into the circular state, you should keep on broadcasting all the information. This is an explicit statement that is made in the eliding RPL info. This is great because it solves the problem in a nice context specific way. I'm just wondering if something like this can be can be thought about at least. It may not be possible to handle it in something like this way for all the other school lollipop counter, but if it gets handled in this way, something like this way, I'm just saying, that would be great.
Makes sense. But for existing RIPL, even if you write an errata or something, it's not even an errata. An errata is really a correction for what exists. It's not for adding something new. But the implementations are already there. So that's why I'm more interested in focusing on RIPL v2, where we can really say, the starting point, you can expect to have this. So let's make sure we have a clear list of what we want to make sure we have in RIPL v2. And that's why your document is so critically important.
So basically what we're saying is we'll put something specific to RPL v2, and then we can think about how to handle the sequence window, and if we can make use of some context specific information in context to individual lollipop counters, we'll see it there, right?
Works for me. I'm sorry for being late, guys, but did you already discuss the capabilities draft?
I don't think we are discussing capabilities draft in this interim.
Okay, because so I reviewed it, but maybe we can work as co-authors. So I'll sync with you, Raul.
Okay, that's it from this set of slides, I guess. Next slide, please. Let me just check if there's another one.
There was another one. There was not. Rock acknowledge.
It's the last one. Okay.
Yeah. So now, if you can see the Pascal slides. Welcome, Pascal.
Thank you, Ines. Did you give me the bar? I'm LP1 working group. Don't ask me, but that's because I use it just as you do. And I guess you will appear as whole working group when you log in somewhere, Ines. Just the memory inside WebEx. So please give me the bar. No? Okay, so
Sorry, I didn't understand what you say.
I was asking you give me the control, but if you want to move the
Okay.
slides, I make one working group.
Okay, I stop sharing now. You should have the control.
Right now, you're still shown as having the ball.
Okay.
So if you right click on LP1 working group and say make presenter.
General to host. Okay, general to presenter. Okay.
Yeah, now I get it.
Now you are.
I am.
Yeah. Thank you.
Okay, but I don't see the slides. So did you upload them or did you share them? How did you?
Okay, I will share them. Okay, wait.
Okay, Ines, offline, let's chat. I need to show you a few things about WebEx.
Okay, now you should be able to see.
Yes, I see my slides.
Okay.
Yeah, yeah, because I expected that you had uploaded them, but you did not.
Yes, they are uploaded.
Okay. Okay, we
Uploaded on what?
On WebEx. We'll talk after the meeting.
Okay.
So let's
Uploaded on the data tracker. I think that's what
yeah,
Ines meant.
that's not what I'm talking about. When you want to give the ball, you want to upload the slides to WebEx first, and then they stay on the screen. You don't need to share your screen anymore. They are just up there. But I need to show you that. So we'll do that offline. So please, next slide. So this is a draft that I wrote sometimes 6 months ago. That's because we had an interim and we agreed that for Ripple v2 we wanted to have a certain amount of functions, a new functionality. And one of those functions was the capability to make sure that all the configuration was up to date. And as you know, with Ripple as it stands, the root decides when it sends the configuration option. And after that, it may not send it for a long time. And the device that just boots or reboots may not get the configuration. And there is no way to know if you have the latest version of the configuration. And as it goes, we are now adding MOPEX capability, I mean, a number of new options and new messages. And we are not clear as a new node joining that you have the latest of everything. So we said, hey, we need to have something to synchronize the database, quote unquote. And that's when I started this draft. So the draft has not evolved because we had other priorities and we're working on use of Ripple, rule, capabilities, all those drafts. But at some point, we still need to move on with this one. Right now, it's a personal submission. It's just what came out of my mind, and I did not get a good chance to talk to anybody. So we can really change it. I mean, it's just a first draft. But since I got no feedback, it's still there. And it was like that at IETF 106. So it's been 6 months, something like that. So next slide, please. So the goal is to make sure that in runtime, when nothing changes, you can have small DIOs and small DAOs, both. So the small DIO would elide all the new options that we're talking about, configuration, capabilities, etc. And the new DAO could elide a number of route entries and just say, same as before. So in the DAO case, it would take us nearer what you get with a link state protocol, such as OSPF or ISIS, when you sync the database. And as long as the last number that you saw has not changed, then you know that your database is up to date. With DAOs, the way Ripple was designed, we repeat over and over and over because we don't know if the guy we send to is there, and we may lose messages. So we believe that by repeating over and over, it will end up working. But there is a cost associated to that, the fact that you repeat your DAO periodically. And so having a way to say, oh, same DAO as before, and if you add it, then you still have it. That's kind of cool as well. So this draft does both compressed DIO options and compressed DAO option. Next slide. So we basically, we could have said, hey, we have a sequence counter per option that we protect. But that would be a lot of sequence counters. So the proposal in this draft, and really that's meant to be discussed, is basically we have a sequence counter for a stable state from the perspective of the root. And that stable state includes all the possible options that we want to protect. I mean, the current ones, and if we have options in the future, and they will also be protected by that single sequence number. So what you really want to know is, for each option that you care about, what is the last configuration state sequence, this RCSS, sequence number at which it was changed. And so by just exchanging, with your parent, here is the RCSS to which I was synced, then you can detect with your parent what you missed and just synchronize that. That's the goal. Now, you will find in the gory details that because we are using section 7 of repo, I mean, the same lollipop thing that Raoul was talking about earlier, we have this comparison window of 16, whereby even if we have a sequence counter of 256, two numbers are only comparable if they are 16 apart. So even if there is no change, every something like 16, you will need to resync. Just now, 16 could be hours or it could be weeks, just depend on how fast you change anything. But every 16 global change, even if they are in option B, you will have to resync every option. Because otherwise you cannot compare the sequence number you have in memory and the sequence number that the DIO is telling you. They can only be compared if they are within a 16 window. That's part of the way repo handles the sequence number, to make sure that we don't have this A less than B less than C less than A that we had in OSPF v1. So that's pretty much it. We have to update the base objects. We change the DIO because we need to say, hey, it's DIO with RCSS blah. Then again, you only increment the RCSS when there is a configuration change in one of the protected options. So it's not that every DIO will have +1. It's only when you change an option somewhere, like the configuration. So you can live a long, long time with the same RCSS. So same thing, we have an RCS, we have to modify the DAO. It's not the RCSS, but you have to modify the DAO to also indicate it's the same as DAO number blah. And then we had to change the dis, and that's when Dominic came into the discussion, because he had other changes. Because we used the dis to query the parent in order to resync the options. So the idea is always the options come from the root and they go down. So your parent is always more knowledgeable than you are. Actually, if you have multiple parents, you will see that in the draft we discuss finding the most up-to-date parent and synchronize. If you have only one parent, that he must be more up-to-date than you are. So you basically sync with your parents. You use the dis to say, hey, here is my RCSS and here is what I want to see. And the parent comes in and will say, oh, this one has not changed, this one has changed. And the last thing that we added is this new AO option. And the AO option is basically an option that contains an option. So when you see the format, an AO tells you, I'm the AO for option blah, like configuration option. So you have this command value, this type, which says I'm an AO. Then you have the subtype, quote unquote, which says I'm the AAO for the configuration option. And then you find the RCSS. So in the subsequent DIOs, instead of placing for option, you might just place the AOO, which will say for this option, the RCSS of the last change was that. For this other option, the RCSS of last change was this. So that's what the AOO allows you to do. Just give for any given protected option what the RCSS was. So if you have a child and it knows the configuration option for RCSS 15, then even if the RCSS has moved to 17, there will be an AOO, which will say for the configuration option, 16 is still good. 16 is the last, 15 is the last change. So the guy who was 15, he knows that he doesn't need to synchronize the configuration option. But since the RCSS has moved, there must be another option that he cares about. So that's how you can place all those options in this compressed form in a single DI. If nothing changes, then just put the abbreviated option to say the RCSS of last change was this. Okay, next slide, please. Okay, so the idea is so far we protect all those options. So we have the MAPAX, we've got the capability that is, well, oh, the slide is obsolete. Now we have MAPAX and we have capabilities draft. I've updated some things, but I failed to update that. So 4 and 5 are the new drafts that Raoul has done. Then we protect the route information option. It's not really used, but it's actually how a given route can reach that particular prefix, whereas another route may not be as good to reach that particular prefix. So it's like the routing option in the array. So the DODAC configuration option is the one we wanted to protect most. And then the prefix information option. If you don't change the prefix, why send over and over the prefix for the DODAC? So it's protected as well. Next slide. And like I said, if in the future we have more options, the same mechanism can apply. We won't need to define a new RCSS. So I introduced the AOO earlier. So here is what it is. There's an option type of option length that says, hey guys, I'm an AOO. Then you've got the abbreviated option. So the option that you are abbreviating, which is one of the 5 that we just saw. And then you have the RCSS where that protected option was changed for the last time. That's how the child can see, oh, it was not changed between there and now, and the last I knew, so I have the latest. Next slide. So the this was changed to place 2 things. And I'm not 100% clear that we both. One thing was a set of flags to indicate which option the child wants to get. And the other is the RCSS that the child was synchronized to. So if the RCSS is now 17 and the child was, last thing it saw was 14, then the child will say 14. Now, if the child says 14, then the parent should be able to say, oh, here is what he needs. In which case, the parent doesn't really need the 5 bits. But I place them as well. Now, if we decide that we don't need that, then the 5 bits on the left. Maybe we could avoid them. Those 5 bits is 1 per option. Basically, the child could say, hey, I want to get option blah. It just sets the flag. Now, it's two ways of asking something from the child perspective. I thought it was better to be able to ask with a fine grain whatever you wanted, but maybe somebody will tell me it's useless. Anyway, you need one of the two. You need to be able to say, hey, here is my latest state. Please give me the latest for everybody. Next slide. And now I will ask you guys to read. This is basically a summary of the rules on how the RCSS works. And if you don't, I really wanted to discuss that on this call because I wanted you to have a chance to look at that text. So it's the important piece inside the draft.
Looks like a note one.
Sorry?
It looks like a note one. Please read.
But this time I will give you time.
That's why you missed the note one.
So Raoul is telling us that some lag. And if you upload the slides, as I indicated, You don't have this lag. It's one of the benefits. So Ines will stay, if you don't mind, will stay at the end of the call and I will show you.
So Pascal, I have a question. I'm wondering right now. The draft changes the base objects, right? So is that what you're trying to say, that this thing should be made use of only from RPL v2 and
Yes.
base? That's the point you want to convey there.
Mm-hmm. I would like to make sure that if you have a RPL v2 implementation, it has this thing, but you cannot ask a RPL v1 to understand. So it's supposed to be backward compatible in that the v1 will ignore it, but really you will not get the service that you want, so it's kind of useless. So this thing really starts with RPL v2.
Yeah. But it's so if there are any v1 nodes, basically they won't be able to join the network at all, because I mean, once the RCSS starts getting sent and the RPL v1 node tries to attach, it won't know how to query and all those things. So only the RPL node can be there.
Above 7, right? I mean, the goal is when you start playing with this, you will be having a map above 7. So the node will join as a leaf or something.
So eventually the node will join as a leaf.
There is a lot of noise, so I could not hear your voices. There was some additional noise, however. But yeah, I guess we agree. I mean, the idea of the capability of this, etc., is to agree on the baseline that we want to have day one for RPL v2, make sure that every RPL v2 node will understand those things. So that will make a huge increment that will justify having a v2. So did everybody read those 5 lines?
Yeah, Pascal, I have one question. Do you have separate RCSS counter for each of the protected options?
No.
Apart from the group, no?
That's a design point that we want to discuss, maybe. But I mean, having to send too many RCSS and keep in memory too many RCSS looked like an overkill, because most of the time nothing changes. So having a single RCSS that covers every option and changes every time any option is updated looked like better. So when you increment RCSS, you may change all options if you want to, or you may change only one option. But each time you change any of the option, the RCSS must be incremented. So for each option, go ahead.
So let's say if any option change, we have to always change the global RCSS option of DIO. And in abbreviation option, right, whatever new option you have introduced, there for each of the options, we have to send the RCSS counter also, right? And all will have the same value, right?
Exactly. That's why you have the AOO, because for each option, you will have the latest RCSS at which this option was changed. It's a way of doing it.
But it will be same for all. So all the protected
only
options.
one sequence counter, only one RCSS. It's the RCSS of the DIO, not an RCSS of the option. But you don't increment the RCSS if nothing changes, right? You just increment it if something changes. I mean, if you find there's a problem with that, go ahead, because it's just a proposal on the table.
Yeah, I think this and RCSS currently takes care of options which rarely changes. That is the right way. If you PIO is something which rarely changes. So configuration option is another thing which rarely changes. So these are the things we should.
Yeah, that's part of the answer. Yes, if things don't change much, having a single counter for them all.
Okay.
Now, like I said, if you have one option, the way it's designed right now, if you have one option that changes a lot, after 16 changes, you will have to resend all the other options in full, because otherwise the sequence counters are no more comparable. Or we need to change the window in the sequence counter from 16 to 32 or something like that.
Oh, okay.
Remember, in REPL, we want to avoid the traditional sequence counter issue whereby A would be less than B, which would be less than C, which would be less than D, which would be less than A. Because of the going around the circle. And the way we avoid that is we can only say that A is less than B if they are less than 16 apart. So you see with a counter of 256, A less than B, B less than C, you can never have C less than A. Never have, I mean, it would take a large number of numbers to go around the circle. So that's the trick that we have in REPL, to make sure that we always know that we can compare the numbers. But if two numbers are more than 16 apart, with REPL, they cannot be compared. And that's how you realize that one of the two numbers is stuck. There is an error somewhere. And they become not comparable. So can we go to the next slide, please, Ines? So the child can set the bits for the options that he wants. So if he gets an RCSS which is blah, and he has the AOO, which say for each of these options, here is the last RCSS at which they were changed. All those which were changed since this child synchronized, he knows he need to resynchronize them. So he will set one of the, or several of the bits to say I want this option, this option, this option. Now the child will also say at which RCSS it was last synchronized. So like I said earlier, it can be duplicative fault. Because if he says I was last synchronized at this RCSS, the parent could figure, oh, then he missed this. So there's no point for a child to ask. So as we design, we'll figure if we need the bits or the last synchronized RCSS or both or what. But right now I've proposed both. Also, you can send more than one DIO message if you can't fit all the options in one. So you have to send them in a short window of time. But actually, most of the options are replaced by AOO, in which case the message is not that big. For instance, if the child says, I want all the options, but he sends an RCSS, which means that some of the options are actually still good, then you can just send the AOO for them. So just giving an example, this child has persistent memory. It has synchronized to RCSS 200. Now time passes, the child reboots, and he sends this, and by default he thinks, oh, I rebooted, so I don't know. So let me set all the 5 bits. I want to see everything, and my last RCSS was 200. Now the parent knows that we are at 205. So he will place in full all the options that changed between 205 and 200. And for the others for which the bit is set, he will just place the AOO, saying, don't worry, this one was changed on 199, so you don't care.
The last sentence saying that the DIO messages must be sent in quick sequence or within short period of time. This that worries me a bit. It's always space for implementation problems, and that might make a difference if you use one way of querying, which is the RCSS, or the other way, which is the flag. Because if a node says I want RDPMO and you get RDP, then it figures, well, my parents heard me, and since I requested MNO, it will probably come back soon with MNO. Whereas if you ask for currently at RCSS number this, and I get RDP, then you might decide, okay, then MNO probably haven't changed. And the soon needs to be sooner in the latter case. Does that make sense?
Scratching my head. So did you say, hey, I will ask M first and I will ask O later? So I'm sure that everything fits in the DIO?
No, I'm saying if you ask for multiple options and there was not space enough in the message, in the DIO message, so it will be spread over multiple messages, as you say in the last.
That's how I wrote it, yeah?
Right, and so if you query by flag, then as soon as you get the first few responses, you know that your parent heard you and is going to provide likely all the options you requested. Whereas if you query by RCSS number,
you never know. Yeah.
You get a few ones and figure, okay, then probably the other ones haven't changed.
Yeah, that's true. That's a good reason why to have the flags. Because if you ask for the 5, as long as you don't get the 5, even in the form of AOO, then you know you don't have it in full.
Waiting.
Yeah, true. Very true. So it's a good reason to keep the flags.
Good.
Another reason would be
just highlighting a difference.
Another reason would be to pull them one by one. If, for instance, if you're operating on a PHY like 15.4G, you can set all the flags. Now, if you're operating on the old 15.4, and you know that you can't have a PIO and a configuration option and blah, blah, blah at the same time, then you could do 2 disks, one for the PIO and then one for the configuration option. For instance, you grab the PIO, you form an address, you do your stuff, and then you ask for the configuration option, and then you join as REPL, as a router. So you could do things in 2 steps. Joining as a host, for which you need the PIO, joining as a router, for which you need the configuration option. So, yeah, I mean, for now, it's like that. So I'm happy that it works. But we don't have all the details on how intelligently the device can use that. Next slide, please. I think we're close to the end. Yeah, we're at the end. So that's where we are. Mostly where I am, because I did not get a lot of feedback. And so I really hope that during this call, I would get an initial feedback saying, hey, that's the sort of thing we wanted. And if it is, then we can discuss on the mailing list, on how we progress on this. But at least, is it what you guys expected?
This sounds good to me.
Okay, thank you, Dominique.
Thank you very much, Pascal. Yeah, we will raise those issues to the mailing list. And now, Raul, questions? If there is no question, Raul, move forward. We have.
Yeah, I think a review is we should start the review of the draft. So yeah. I've read the draft before, but I think a lot of things have changed since then. I mean, I've read the draft like 4 months or 4 or 5 months before, when it was after the interim. Anyways, coming back to this is about root ACK, and in the last interim, I was calling it rooted DAO ACK or storing mode ACK, something like that. So I decided to call it root ACK for the lack of better name, I guess. Well, so the primary reason why we have this is so that we have some way of end-to-end path establishment indication to the node, so that node can initiate the app traffic. But as it was noted in the last interim, this can be made use of other purposes as well. And the other purpose, one of the other purposes, is indicating or querying the node's capabilities. So this is the only message in storing mode of operation which can directly go from the root node to the target node. Next slide, please. Okay. So we have a K flag. This K flag essentially is set by the target node in the TIO based on which the root ACK is generated by the root. So one of the things that we discussed in the last interim is that we don't need this. We don't need the root to send this root ACK for all the DAOs. We have a flag for that, but then the problem is the intermediate 6LRs don't simply forward the DAO message when they get one. So there is a time difference. There is a delay DAO timer based on which the DAO is generated again from the intermediate 6LRs. So what this means is that the K flag has to be maintained by the intermediate 6LRs. This would be very much similar to how the E flag is handled currently by all the 6LRs. The only difference is at any point of time, if the 6LR sees that it has received a TIO for the same target with K flag unset, it can just unset the K flag for the corresponding it can just unset for the K flag for the corresponding target. Essentially, what it means is that the 6LR has received a K flag as unset because the target has already received a root ACK one way or the other. So that should be that should be good enough handling, in my opinion.
Raoul, don't
Yeah.
you think that's the way you specify this? There will be many ACK root ACK actually coming from the root, because I send a DAO with a flag for myself. Now, for some reason, my parents sends this DAO several times. And if I don't, send another DAO with a K unset, there could be a good number of copies of my DAO somewhere above me. And even if now I send a DAO with a K flag unset, by the time that the K flag percolates to the root, I mean, the root will have gotten the DAO several times. So if each time he sends a root ACK, there should be a sequence counter or something so that you get only one. I mean,
so there is a sequence counter, Pascal. So the path sequence. So if you see, what we are trying to do here is, so the path sequence makes sure that the target node knows the root ACK is generated for which.
Okay, so the root gets a DAO for a given path sequence. If there is a K, it will send it, and the root ACK, and then until the path sequence is updated, there will not be another root ACK. So if the child doesn't get the root ACK, he needs to increment the path sequence, even if he doesn't, well, he has to. So he will increment the path sequence, and then he will reset the K flag. Okay, so
yeah, so this is one of the primary design point that had to be taken care of. So what happens if a root ACK is sent for a old DAO? It should not matter, frankly speaking, for the problem statement that we are that I initially imagined for the end-to-end traffic establishment. It does not matter, but it is good to know that the root ACK is initiated for which DAO. So yes, it handles it. Next slide. Yeah, thank you, Pascal. Next slide, please. So this was one of the discussion that one discussion I had offline with Rabi, and then we had I had some feedback from Pascal as well online. So there is a RPL unaware leave, and it's making use of RPL network as a transit network. And in this case, even the rule needs to know when to initiate the application traffic. And there is an NA ERO with EROs that are sent in unaware leaves draft. So Pascal, you suggested that the NA ERO should be generated only on getting the root ACK back from the root. This, I think, this is a completely stateless operation, so it should not be. I mean, from implementation point of view, they should be okay to handle. However, I'm just wondering. So, if I simply make change in this draft, will it be okay? Because if currently unaware leave draft basically sends a NS and gets a NA ERO as quickly. So, what happens? I mean, a rule does not have to change, but is there any? I'm just trying to think if is there any dependency on the unaware leave draft for this?
Here I have one point. Let's say if we send the ARO ACK based on the end-to-end DAO ACK, in that case, maybe if there is a negative acknowledgement from the root, maybe we have to send a new status in the ARO message. In the
That's
NA,
right.
when we're sending the ARO, we have to add a new status information.
New status as the ERO already has the status, right? So you're saying that status has to be updated based on the root ACK.
Yeah,
No?
let's say root ACK failed because of something. We get a negative acknowledgement from the root.
Okay.
In that case, we have to send a negative. Means it has a negative ARO. We have to send, right?
Right.
When we are sending a status back to the RUL, in the EARO option, we have to send the proper status. Why this registration failed? Maybe there we need a actual reason. Maybe that status field we have to add.
There is a status already in ERO. Can't
No,
we make use of
that value, whatever is defined currently
Okay.
in the RFC, that this is not handled. This part.
Well,
This
there is
failure.
a difference between the messaging by which the C in this picture gets the prom and what he has to tell the rule. What he has to tell the rule is one of the statuses which are specified in the RFC that defines the NSCRO. It's not REPL that defines that. It's 8545.
Yeah.
So
Yeah,
if we are missing something in 8545, then we'll have to update it or something. But it's not because it comes from a root ACK versus a DCO that it makes a big difference. Right? Normally the root ACK is just to tell you, hey, your route is enabled. It's mostly like if you receive it, it means okay, even if there is nothing in it. It just means okay, the root can reach you. Now, if there is a prime, normally the root would send an asynchronous DCO. So that's how I see it. The root ACK is more like confirming that I got it. The root ACK is a unicast. If there is a prime from the root, for instance, the state in B would be maintained. Right? The root ACK would not clean B. It would just clean C if you wanted to clean C. But if you really want to clean B, then the only thing the root can do is send a DCO.
Right. Yeah.
So irrespective of root ACK success or failure, address registration is going to be success for RUL, right?
Yeah, I mean, pretty much. It's just something to hold. So basically, C is ready to send the NA ERO, but it has set the K flag. So now it needs to hold sending the NA ERO till he gets the root ACK. When he gets the root ACK, it just unlocks sending the NA ERO. But the root ACK just confirms that the connectivity has been established. It's not supposed to mean anything for now, because as a separate discussion, we can talk about capabilities. But for now, it's as specified. It would just mean, okay, the DAO has percolated all the way to the root, and that's it. So the root can reach you.
Yeah, That's right.
So it's just unholding the NA, but the NA could have been prepared already. The idea is not to give a bad status at that time. Because B would not know.
That's right. So if actually the route has to be cleared up for some reason, then DC has to be made use for clearing up the route.
Yeah,
Still carried as part of it. Yeah.
Yeah.
So one more thing that has to be clarified as part of this slide is that currently in the draft, the route ACK carries only the transit information option. But now with external targets, the route ACK needs to send back the target option to the 6LR, that external target. The reason being, otherwise, you need to know for which external target was this route ACK been generated.
Yeah.
So yeah, that is. I think this should not be a big problem, but yeah, that is something that has to be explicitly added in the draft. Next slide, please. Okay, and then we have this capability query. I mean, I just wanted to depict a picture saying that now there is a way in which root can send an asynchronous root ACK. Now this is where this nomenclature of root ACK does not make sense because in this case it's no more an ACK, it's a capability query. So this is where I wanted to see if we can come up with some other name. But basically here we are, asynchronous root ACK, and then we send it out with the capabilities. So this point can be handled like this. The capability queries can be handled like this.
But here, like this capability C would have shared with B already, right?
Yeah,
This capability is also for the like use in a DAO projection kind of thing, right?
Yeah, so let's say for example, root wants to know what C has or what C supports, right? So if root wants to know, if let's say for example, root wants to install a route, PDAO, projected DAO, then root needs to get some information from C. So this is one way to get that information. This is the way to get that information because this is the message that can be directly sent to root, sent to the target. Sorry.
Yeah. How last time we discussed how I thought that this exchange would be a new message. So
it's a new message, but I'm not sure if the name is correct. So if you're talking, so it's a new message, right? I mean, you're saying it's not
a new message, but then the DAO is not. And for me, the new message would be root sending a query and the C sending back the response to query. So like capability query and response.
I think these two we can keep separate, Rahul. This DAO and root ACK and capability query can be separate.
Well, the thing is, the root ACK is only needed if there is nothing else. Like if, for instance, you're in a situation where each time there is a DAO for which the root doesn't have the capability, you're sure that the root will come and query the capability. Or if there is anything else, then, for instance, if C is a 6LR and it does a DARDAC exchange for a RUL node, then he will get the DAC back, meaning that is reachable. So if you remember the way neighbor discovery is written, there is something that says that NAD is only needed if you don't have any upper layer information telling you that the connectivity is still going on. And same thing, this root ACK would be only needed if there is no other message that's going around that shows you that you've got connectivity. So if you're doing this query, then you don't even set the caveat because the query is coming and that means you're reachable.
That's right. Yeah. But Do we want a separate message for this then?
Yeah, I think so.
Okay. So we can completely decouple this these 2 points then. Yeah. So this can be part of the capability draft rather.
Yeah.
Put up somewhere here, right?
And this draft would say, hey, if this or anything else is going on, that makes sure that C is reachable, then C doesn't need to set the K bit.
I think this is better. Okay.
In two scenario, this root ACK is required. One, when the node joins the network first time, or it did some parent switch. In those scenario, maybe the root ACK will be used. That's what I think.
For the parent switch, what is the reason, Rabi? I mean, I know in our previous implementation we used that, but I still think maybe for the parent switch, maybe.
But that because I have switched a path, then I have to know that in that path it is reachable, right? That's
Okay.
what root ACK will ensure. See, I am now connected to B because of something I moved switch to C, switch to A. But via A, I might not be reachable because of some issue.
Yeah. Actually, this is what we did in our implementation anyways, right?
Yeah,
So,
correct.
yeah. That's all. I think this is the last slide. Next. All right.
Thank you very much, Raul. Further questions? Raul, you mentioned that when Pascal joined, you would like to back to some slides, if I understood correctly.
No, what is it was if Pascal is not back, then I can present some of the points with regards to eliding RPL info, but he has already done that, so there's nothing for me to say.
Okay. So, okay, we will collect the action points for this meeting, and we will send back with the mailing list with the link to the recording. So, you would like to meet in June?
That would be nice.
I'm open to meeting in June. Yeah.
Okay, to continue working.
Ines, I guess as chairs, we have to, for our own working groups, we have to request a meeting for virtual 108, right?
Yes, there was a discussion at the beginning what the working group would like to do, like meet during IETF 108 or later, because we are going to have 2 slots. I mean, we discussed that with 1 slot will be enough if we meet during IETF 108, or have an interim of 2 hours later.
If we do interim,
At the notes in the Etherpad, there were split opinions on whether having a meeting during that week or having a separate interim meeting. What's your opinion? Would you like to have a meeting within the IETF week, Pascal, or rather not?
Not necessarily. I really loved the way we did it last time. So we spread over 1 month, so we could find the best time for each group. So, I mean, the reason why everything is packed is because we travel. Otherwise, doing what you just did for finding this particular slot is really perfect because we can really find where we get most attendance. So I don't mind it's that week or another week.
Okay, and 2 hours is fine, right? 2 hours, I think, no.
Yes. Yes, my vote is just do what you did for 107. It was really great.
Okay. Thank you very much. We will anyway request compare with the mailing list and collect all the information. Okay, there is no further questions.
No, please come back to me on the eliding thing, because I still didn't get a good sense that the group wants it or not. And well, I invested time on it, so I would love to see if we want it or not.
Okay. Okay, I will stop recording if there is no further questions now. Oh.